Hello everyone, welcome to AJJ Engineering. Today I would like to discuss with you about plastic injection molds under mold technology. Introduction. The function of the injection mold is to give shape to the part and to cool the molded part. A simple mold is made up of two components. One is the cavity and the core. The mold, which is made for one or more parts, consists of two basic elements: a stationary mold off on the side where the plastic is injected and the moving off on the closing or ejection side of the machine. It is important to design a mold that will safely absorb the forces of clamping, injection and ejection. The flow characteristics of the material and the part cooling prior to removal of the part from the mold should also be taken into consideration. It is important that the designer or mold maker first understand terminology of the injection molding process. Some of the basic terms are described in this chapter. Basic terminology. Injection mold. An injection mold is an assembly of parts into which molten plastic material is injected and allowed to cool inside so that it assumes the required shape. In the picture we can see different parts of injection mold. We have toe plate, cavity plate, core back plate, support plate and bottom plate. We have ejector systems, ejector plate, ejector retainer, ejector pins, propeller, etc. We do have guide pillar, guide bushers and sliding bushes. On in the exploded view of the mold we can see locating ring, sprue bush. Those things are directly helps mold to mount in the machine. Injection molding machine. An injection molding machine is a machine for the converting, processing and forming of raw plastics material of powder, pellets or regrind into a part of desired shapes and configuration. In the picture we can see that the machine has moving pattern and fixed pattern. The mold is getting mounted between these two patterns and we have an injection unit through which the material processed and injected into the mold. Injection unit. An injection unit is a part of the machine which forces the material into the mold. In the pic we can see that in injection unit we have a screw inside a barrel. Heater is covered the barrel. We have material hopper, screw motors which turns the screw to push the material inside the mold. Molding or component or part. The term molding refers to the parts produced or mold itself. Impression. An impression is the part of the mold which gives shape to the molding. The impression is formed by two mold members, namely core and cavity. It is the empty space between the core and cavity when they are closed. Cavity. It is the female portion of the mold and gives the external form of the molding. The cavity can be integral type or of insert type. If insert type, it is mounted on a plate. Core. It is the male portion of the mold and gives the internal shape of the molding. The core can be integral type or insert type. If insert type, it is also mounted on a plate. Cavity holder. The plate in which the cavity insert is fixed is known as cavity holder. Cavity bolster or cavity retainer plate. Core holder. The plate in which core insert is fixed is called as core holder, core bolster or core retainer plate. Sprue bush. During the injection of molding process, the material is delivered nozzle of the machine as a melt. It is then transferred to the impression through a passage. This passage is tapered hole within a bush. The material in this passage is termed the sprue and the bush is called as sprue bush. Thus, the sprue bush can be defined as the part of the mold in which the sprue is formed. Sprue bush is the connecting member between the machine nozzle and the mold face. Should be made from 1.5% chrome steel and should be hardened to withstand the stresses. The backward movement of the sprue bush is prevented by stepping the end fitting a register ring, which serves a dual purpose of securing the sprue bush and mold location. The internal aperture of sprue bush has an inclined taper of 3 to 5 degree, which facilitates the removal of the sprue from the mold. The taper should be highly polished. There are two basic types of sprue bush. One, sprue bush with a spherical recess used in conjunction with a spherical front-ended nozzle. Sprue bush with a perfectly flat rear face and a corresponding nozzle is used. If the alignment between the nozzle and the busher aperture is perfect, a leak-free joint is achieved with the spherical seating. However, misalignment results in a gap and leakage occurs. But in case of flat-faced nozzle, no leakage can occur if the two apertures are slightly out of line. Runner. A runner is a channel machined into the mold plate to connect the sprue with entrance to the impression. The runner can have different shapes like half round, full round, trapezoidal, etc. Gate. A gate is a channel connecting the runner with the impression. It has a small cross-section area when compared with the rest of the feed system. The gate shape can be rectangular, full round, angular, etc. Register ring. The nozzle and the sprue must be correctively aligned if the material has to pass without hindrance into the mold. By introducing a register ring, the mold can be aligned to the machine nozzle. The register ring is a flat circular member fitted on the front face of the mold. Its purpose is to locate the mold in its correct position on the injection machine pattern. When the mold is mounted on the machine, the register ring fits into a circular hole which is accurately machined in the injection pattern on the cylinder nozzle axis. This ensures that the aperture in the nozzle is in direct alignment with the sprue bush hole. The register ring forms a direct connection between the sprue bush and the hole in the injection pattern of the machine. Spherical seating and flat seating. Register ring is located on the outside diameter of the sprue bush. The register ring can also be located on the stepped end sprue bush where the register ring secures the sprue bush in position. In case of a mold which necessitates a long reach nozzle, the register ring cannot be located on the sprue bush. The register ring is located in a recess in the rear of the injection holster. Guide pillar and guide bushes. Guide pillar and guide bushes are used to align the core of and cavity of. To mold an even wall molding, it is necessary to ensure that the cavity and core are kept in alignment. The guide pillar has its working diameter smaller than the fitting diameter and a flange is provided on the fitting diameter side. This stepped pillar has certain advantage over a constant diameter pillar. If the working diameter is bent in case of it can easily removed without damaging the fitting holes. But the attempt to remove a bent constant diameter pillar will damage the fitting hole. A guide bush is incorporated in the mold to provide suitable wear resisting working surface for the guide pillar and to permit replacement in event of wear damage. Heel blocks. Heel blocks are the steel blocks mounted on the backplate to support the mold plate. Heel blocks provide a space into which the ejector plate assembly can be fitted and operated. It is also known as support rail or support block or spacer block. Ejector. Ejector is the part of the ejector system which applies the ejection force to the molding. There are different types of ejectors used such as ejector pins, ejector plate and sleeve ejectors. The types of ejectors selected depends on the component shape. Ejector plate. Ejector plate is used serving the purpose of transmitting the ejector force from the actuating system of the injection molding machine to the ejector element. Ejector retainer. Ejector retainer is a plate securely attached to the ejector plate for the purpose of retaining the ejector. Sprue puller. It is necessary to pull the sprue from sprue bush after each injection for further injection of melt into the mold. Sprue puller or breaker is used to pull the sprue out of the sprue bush as the mold opens. There are different types of sprue pullers generally used. Undercut can be provided on the either pins or bush retain pin. The pins or pushback pin are incorporated in a mold to push the ejector system to its rear position as the mold is closed. Rest button. Rest buttons are small shoulder pin cross-fitted or disc screwed to ejector's plate or base plate to reduce the contact area and provide some space between ejector plate and bottom plate. Possibility of ejector element remaining slightly above due to the foreign matter being wrapped behind the ejector plate is avoided by using rest button. Fixed off. The half that is attached to the stationary platen of the machine is termed as the fixed half. Generally, cavity is fixed in the fixed half. Moving half. The half of the mold attached to the moving pattern of the machine is known as moving half. Generally, the core is fixed on the moving half for easiness of actuating the ejector system. Attachment of mold to plate. There are two ways of attaching the mold halves to the platen of the injection molding machine, and these are either directly by means of bolts or indirectly by means of bolts and clamps. For direct molding, clearance holes or slots are provided in each molding half, holes tapped in the machine platen. In direct clamping, mold is clamped on the platen by means of a flat clamp and bolts.